This meeting is being recorded.
Okay, so from last week, we discussed few things, right? So we discussed about OSI, we discussed about switching concepts, switching fundamentals, and how do we use separate broadcast domains for different departments, and how do we make sure that we have avoiding the loops in the network, and also how do we make sure that we have high availability in the network. So we discussed about topologies, different types of networks, how they connect, and how do they fail over if one device fails. We discussed about spanning tree. In that fashion, we discussed about electing a root bridge and all of that, right? So today we're going to talk about, I know we stopped in the middle of LACP. Today we can discuss about like link aggregation protocol, and how it is separate than a standard protocol, standard port channel with the mode on. We'll discuss that today. So quick recap. Let's do. Varun, can you tell me what are the 7 layers of OSI model?
Yeah. Physical, data link, network, transport, session, presentation, and application.
Okay, got it. Thank you. Next, Sai Shri, can you tell me what is the difference between access port and trunk port? Sai Shri? Okay, so access port is like when you have a single VLAN, you are attaching a VLAN to the specific port. And for example, like an endpoint device, like a PC or a phone or a server, where you will put the entire physical device into one specific subnetwork. That is where you will put the port in the access VLAN. Trunk port is like allowing multiple VLANs. We discussed about having a hypervisor or a VM, couple of VMs in a physical box, and we wanted to separate them. So we do use a protocol called 802.1q encapsulation, and so that we separate both the VLANs and we trunk them with the .1q encapsulation protocol. So that is the difference between access versus trunk port. Okay.
Actually, I don't think we discussed this thing in the class. Like whatever you ask now.
I'm pretty sure we did. Next, Ritik Tota, can you tell me what is spanning tree?
Basically, spanning tree is it's used to overcome the loops, and also it calls them broadcasts and storms. It also creates a duplicates, and when the switches goes down. So to avoid this, we basically we use the spanning tree, and also this spanning tree it is for it has the normal. So to multiple switches and to multiple parts, the data transfers.
Your answer is not very precise, but it's like randomly moving here and there, but I understand the context. So you're saying spanning trees to avoid the loops and to reduce the broadcast drops. Okay, yeah, I think you are there, but I think it needed a little bit more clarity. So please go through the recording one more time to get that clear understanding. Next up, Avinash Bopudi. Can you tell me how do you have redundancy in the network layer?
Hi, this is my first class.
Have you gone through the recordings?
Not yet. I'm going through.
Okay, so have you gone to the first class?
No, not really. Okay.
Yeah, I think you have to go through all the classes before you join the live. You will not have any context, brother. If you don't know that, there is no point of following this. So please make sure by tomorrow, do that extra mile and complete all the recordings, okay?
Okay.
Yeah. Hari Prasad, can you tell me what you do to have multiple links acting as a one logical channel?
I think we use port channeling.
Correct, thank you. Aruna, can you tell me what do we do in the spanning tree to elect the root bridge?
We will do, we have to find the lowest MAC address. Can you tell the question again?
In the spanning tree, how do we elect the root bridge?
Hmm,
I think the priorities.
Yes, that is correct. So we
Bridge
change the
ID is
priority.
equal to priority plus MAC ID, MAC
Yeah.
address equal to lower.
So we change the lower priority, that will become the
Yeah.
root bridge. Yep, that is correct. Okay, I think we can start for today. Thank you guys for answering the questions. If you do not understand the answers for the questions, please go to the previous recording. Make sure that you answer yourself. It's really important so that it will help you to move into the course, not to get stuck or not to get lost in the woods. Okay, so let's talk about port channels in a little bit more detail today. One second. Okay. So LACP. So there are three modes of port channels. So one is failover or static bonding.
I have a question like these comes under port channeling you're saying or
Yes, last week we stopped about talking about port channel, but we did not go deeper into LACP and different types of port channels. So we are starting where we left in the last class. That is
okay,
correct.
these are the types of port channeling, right?
Yes, these are the types of port channeling, correct.
Okay, thank you.
Static bonding or mode on. LACP. PAGP. So when we are bonding two devices, right? Let's repeat the same here. Let's repeat the same. So the concept of having a port channel is like sending the traffic to make sure that we are creating both of the links as a single link. That is the concept of having a port channel, because we are logically bonding them into one logical interface. But it's called static bonding, mean like you will put this interface and this interface configuration as mode on, mode is equal to on. And here also you put mode equal to on. When you do mode equal to on keyword, that means that you are creating it as a standard static bonding. So what is static bonding? So meaning you are manually saying that bond into a port channel on both sides. It doesn't negotiate by itself talking, hey, what is your speed? What is my speed? What is your duplex? What is my duplex? What is your configuration? What is my configuration? It does not negotiate using a protocol between them, but it will automatically form the bond when you create the mode on. It does not negotiate between the links to make sure that it is allowing the traffic or not. For example, let's say this link speed is 1 gigabit per second. This link side speed is 10 gig. So even though you have a 10 gig link, because of this 1 gig link, these two doesn't negotiate and it still forms the bond, and the traffic is going via this link and the traffic is going via this link. But because of the speed 1 gig, the speed will be only 1 gig, but it still will be participating in the traffic flow. But this is not a good method, because we are limiting the speed to 1 gig in this link, and we are still using to load balance on both the links. But let's say this is 10 gig and this is also 10 gig. So this link can have the capacity of 10 gigabit per second. This link can have only capacity of 1 gig. But because of doing the mode on, we were using both of the links and we are not getting the right throughput on both the links, because we are not negotiating anything. We are just manually configuring it as static port channel. Let's talk about LACP here. LACP is an open standard, meaning like any vendor supports it. It's not only Cisco, like Juniper, Arista, any vendor that is out there will support LACP. So using the LACP, both the interfaces negotiate to form the port channel. For example, when you do like mode is equal to active, so when you do mode is equal to active, that means that you are doing LACP. So what does this do means? Both the links will negotiate on both sides. For example, if the speed is 10 gig here, if the speed is 1 gig here, the LACP does not come up. This link will not be participating in the port channel because the speed mismatch is there. Similarly, the duplex mismatch. Duplex means sending the traffic and receiving the traffic in both ways. That is called full duplex. For example, let's say there is a road. This road, if it accepts the traffic from this way and also traffic from this way, that is called a full duplex. Half duplex means either the traffic can go this way or the traffic can go this way. At a same time, both paths will not work. That is called half duplex. So what is the problem with this half duplex? Only this side traffic will go, and this side traffic should buffer and wait until this completes, and then this side traffic will go. So there is a slowness in this traffic flow. Just think about like a road. In the road, only one car can go. After going this car this way, the next car can go from here. So that's like a half duplex. But full duplex is like having 2 lanes. where you can have one car go this way and the other car go this way parallelly. That is called a full duplex. So in this case, if this link is half, if this link is full, the negotiation does not happen. I mean, the negotiation does happen and the link will not come up. So those kind of negotiations will happen in the LACP. And in LACP, you can use 2000, can you mute? Thank you. On the switch one, so on the switch one, we send the data to the switch two, right? We can make sure that you can put this mode whether to be in participating in LACP or not by using a keyword called passive. So let's say this side you put it as passive, and this side you put it as active. But this link will still allow and receive the traffic. Let's say you put this link in the passive. Let's say you put this side as passive, then the link will not go. So what are the combinations? Active, active. Traffic will go. Passive, active. Traffic will go. Passive, passive. The traffic will not go. So you can have that negotiation in the LACP where if both sides are passively set, then that link will not be participating in the LACP. If you want both the links participate, you can put in the active state. Similarly, PAGP. In the PAGP, you send the traffic, you receive the traffic, both, but this will be supported only on the Cisco proprietary devices. For example, like Cisco switches, Cisco devices can only support PAGP. No other vendor support PAGP. It's a Cisco proprietary. The full form, I forgot to tell the full form. So LACP stands for, PAGP stands for Port Aggregation Protocol. LACP stands for Link Aggregation Control Protocol. That's again the book terms. But the concept they do is they negotiate between both sides. Even this protocol does negotiation on both sides. The speed and duplex will be negotiated. The modes, so modes are on both sides. The modes are different. For example, on the PAGP, it could be desirable. Let's see. Not right. Some reason. Okay. Got it. Mode is equal to desirable. Mode is equal to desirable. So if both sides are desirable, the traffic will flow and it participates in the traffic. But what if the one side is auto and other side is desirable? Still the traffic will flow. But what if both sides auto and auto? The traffic will not flow. So let's do a table. Maybe PAGP and then LACP. Let's say link, let's say switch one, switch two. Result. So in the PHEP, the modes are auto. And then switch to auto. Desirable. Auto. Desirable. Desirable. So auto, that means the traffic will not flow. Desirable auto, the traffic will flow. Desirable, traffic will flow. Similarly, LAC, passive, active, active. Passive, active. Say passive, active, passive.
Is there any logic behind them, or just we need to memorize?
There is a logic. We discussed about the logic, right? So when you put the mode
I mean,
on,
like auto, like the terms.
yeah, or the terms. No. I mean, it's you have to memorize it. That's it. Yeah.
Okay.
Yeah. So passive, then the traffic will not flow. Active, passive, the traffic will flow. Active, traffic will flow. So that's how we do they do the negotiation, and then they come to a conclusion whether to put them in the port channel, whether to pass the traffic or not. That's about LACP and that's about PAGP. So the core concept is having two devices. We wanted to make sure that we avoid the loop. At the same time, we use both the links. And for that, we use a protocol called port channel protocol. There are modes of it like which are called LACP or PAGP, or which is called static. Static is basically you configuring it manually without negotiation, but LACP and PAGP are negotiable protocols. The parameters have to match on both sides, like the configuration, like the speed, the duplex, have to match before they form the member in the port channel. That's about it. Now let's move on to the first hop redundancy protocols. Before we move there, any questions, guys, on that topic?
So in static bonding, we just have one mode, which is on, right?
Yes, static bonding is purely on mode. That's it. It's whether you wanted to yes, whether you wanted to no. That's it. There are no different types in the static bonding. That is correct.
Okay. If you don't mind, can you once again explain PHEP? I didn't get that in clear.
LACP and PHGP are same. They both are pretty same, but one is Cisco proprietary, one is not Cisco proprietary, meaning any device can support it. So in LACP and PHGP, the commonality is both are negotiable protocols. The difference is Cisco supporting and one is open standard. That's the only difference. And the whole concept, like negotiation, allowing the traffic, not allowing the traffic, is everything is same.
Okay, got it. Thank you.
So I had a small doubt. Even in PAGP and LACP, the only reason why if there is an auto, the traffic doesn't allow, and then passive, the traffic doesn't allow. It's just because of the negotiation protocols happening between due to the unmatching of speed and everything. Is that the only reason, or?
Good question. Let's talk about it. This is, let's say, a Taco Bell. This is me in the drive-through. There are 3 other people who are in the drive-through. So I ordered a taco. My order went in. Go to the register. But the next guy came. He ordered his taco, but that order is not seeing in the register. What happened? So this order went in, but looks like that order never made it to the system from one window to other window. So you ordered here in the first window, right? And that order is not seeing on the second window. For example, your PC is here, right? So you ordered it on this system, and this system has to pass that to the other side of the system, but that order is not being seen. Looks like one of the link is dropping the packet in the port channel. How do we troubleshoot that? We put one link in the passive state to make sure we take it out of the port channel to see if this link is dropping that order or not. So the reason of putting in passive state is when issues of troubleshooting an issue, to take one interface out of the port channel, you put that in the passive state so that it does not participate in the traffic flow. Is that clear or no?
Could you please repeat once again?
All right. So again, let's say there is a Taco Bell register here. You came in and ordered an taco here in this system. This system should send that same traffic to the next counter where you pick up your order, right? So the packet has to travel through this link or this link or this link or this link. But some of the orders you are seeing on the system and some of the orders are failing. So what might be the problem? There might be a problem with any one of the link in the path that might be dropping the transaction, correct or not?
Yes.
So there is a faulty link here. One of the link is sending the traffic, but it is not seeing on the other side. So there is a faulty link. To identify that faulty link, to make sure that it is not participating in the traffic flow, what we do is we do a trial and error method. So you put this interface in the passive state and let the order go through this link or this link or this link. If the orders are get seen here, that means that this is the faulty link. We will replace a cable or we will replace the interface to a next available interface. We will do something like that. But to make sure this link does not participate in the port channel, in this logical bond, we will put this under maintenance, meaning like we will put it in the passive state. Is it clear now?
So we put a link to passive to find if it's faulty or not. But if we don't find a fault, like if that link is not the faulty link, so we keep on putting the links one by one to passive and check if that is.
Yes, that is a trial and error method, correct. I gave you one use case, but there are different use cases. For example, let's say there is a firewall. There's another firewall. This is active firewall. This is passive firewall. And let's say there is a router. And in that router, you have a link to active firewall and you have a link to passive firewall. And you bonded them as a single port channel. Okay. So you always want the traffic go to active firewall. You don't want the traffic to be flowing in the passive firewall. So in this port channel, if the active firewall go down, then only the traffic should go over the passive firewall. In that scenario, I will put this link in the passive state. Is it making sense now or no?
Yes.
Yeah, there are different use cases. There are different port channels like VPC is there, multi-chassis lag is there, but that is something out of the context here. I don't want to go into that deep level, but think about like a passive interface is used to either troubleshoot an issue or in a failover scenario. That's where we put the passive state of the passive state of the link. Those are the two use cases. But yeah, good question. Let's move on now. Okay. First hop redundancy protocols. I think we already discussed about this. So, but I'm going to reiterate that a little bit. So first hop redundancy protocol. Can someone tell me what is redundancy?
High availability.
No, like we have
having a backup.
backup.
Correct. Having a backup, meaning like if one go down, we have the second one as backing up the first one, just like a standby device. High availability means like the use
Means always available.
It is always available. It is like 100% available.
There won't be
So-
any network shortage, like outage.
Yes, there will be no network outages, or we are providing the customer saying that we will be always up. Our network will be always up. That is what high availability indicates. But redundancy is like having a backup. So let's talk about the redundancy now. So let's say there are two gateways or routers or layer 3 switches, what are you going to call that? This is router 1. This is router 2. So there are two routers. Okay, so this PC IP is 10.10.10.10. So internet is there. So this PC is trying this PC is trying to go to internet. So destination is let's say maybe Microsoft.com. So Microsoft.com. So on this PC, to reach the internet, what is the path? Let me ask Divya. Tell me, for PC to go to the Microsoft.com, what will be the path?
We can go from PC to switch 1 and then from router 1 and then to the internet.
Okay, can you justify your path, Divya? Why only this path?
Like, as we don't have any priority numbers, so
Yeah, there is no priority, Divya, but what made you think it will go through router one is my question. You just took one option, or is there a reason behind it?
I just took it as an option because we have two routers.
Okay, so then tell me, why did it did not take this path then? PCE1 to switch one to router one to router two, and router two to the internet. Why did it did not take that path? I'm sorry.
I mean, like, compared to the switch and then to router one and then to internet, it's the shorter one. So yeah, that's why, like I said, the from switch one to router one and then to internet.
Okay, so you consider a shorter path to go
Yeah.
from PC to switch one to router one, and router one to the internet. Okay, so that is you're justifying your shorter path.
Yeah.
But PC to switch one to router two to the internet is same path, right?
Yeah.
Do you have any justification on that? Okay. Anyone have any ideas?
Router one has less priority.
Priority of what? I mean, are you talking about a specific protocol priority, or you're talking about what? I mean, are you linking it to any protocols that
Like,
we discussed until today?
Yeah, like a bridge protocol data unit.
Yeah, so the bridge protocol works in which layer?
Layer 2.
Is router a layer 2 device?
No.
Then how can we do the priority at the router using the bridge ID?
Based on IP address.
Based on IP address what?
Like,
Router 1 and router 2.
So you're saying router 1 has an IP address, router 2 has an IP address.
Lowest
like
IP address.
depends upon port number.
Okay, let's start with let's talk about the IP address. So Lakshmi, you are saying lowest IP address will have the more priority, so that's why router 1 is preferred than router 2. We are assuming here router 1 has smaller IP than router 2. That's why you chose router 1 path.
Yes.
Okay, that's one theory. Okay, and the next theory is what? Sorry, someone said about port numbers. Can we elaborate on that, please?
I was thinking like we take that like which has like less port number.
Port number, what port number, sir? You're talking about TCP port number?
Yeah.
Okay, port number, TCP, at what layer the TCP works?
Maybe like router 1 has less port number.
No, answer my question. At what layer TCP works?
Layer 1.
Dude, you're killing me.
No, I was confused with your question. Like you're asking me about like which
In
port are
OSI layer,
okay.
what layer TCP works? Anyone?
Transport layer.
Yeah, it's a transport layer protocol. It is to identify what port we are making a connection to the destination. Like HTTP port number is 80, SSH port number is 22, DNS port number is 53. So everything is a port number based. That is at the transport layer. It is nothing to do with an IP layer or network layer. That is layer 3. So a PC does not understand a network path using the TCP or UDP port numbers. No routing will be calculated or altered using the port numbers. That is out of question here. Okay, all right. I think a lot of answers. Some of them are very close. Some of them are very far. But the closest answer is the IP address, which is like the smaller IP address, is what that was given. But here we use a protocol called, actually there are 3 protocols. Let's talk about those. HSRP, VRRP, GLBP. Again, the full forms are hot standby routing protocol. Virtual router redundancy protocol. Any guesses for GLBP?
Global.
Gateway load balancing. Okay, so the names, if you closely look at the names, hot standby, meaning like if this one go down, this is the standby. Next is virtual router redundancy, meaning if this one go down, this one is. Next one is gateway load balancing. This is little different than these two because it is load balancing, meaning it is sending the traffic onto this one. It also sending the traffic to this one. It is using both the paths at the same time. That is why it's called load balancing protocol. It is balancing the load on both sides. So the names itself explains a lot of things on these protocols. But let's today talk about HSRP today, which is the hot standby routing protocol. So for example, the PC to talk to internet, what will be the protocol that will be mapping the layer 3 to layer 2? What is binding IP address to the MAC address? What is that protocol called? Anyone? What is the protocol that will be mapping layer 3 to layer 2? I think let's give it a chance to Manogna. What will be the protocol that will be binding layer 3 to layer 2?
Maybe the gateway load balancing protocol.
No.
Internet,
Nothing
internet
on
control,
these 3.
internet control protocol.
Internet control protocol. I never heard of that. Wild guess, but that's fine. Anyone else? Guys, you know this? If you
Address
don't know,
resolution protocol.
yeah, who is that? Who told that?
Divya.
Okay, thank you, Divya. Beautiful job. Address resolution protocol. The ARP will map the layer 3 to layer 2. We discussed this already. So what is ARP doing is, it is sitting on the layer 3. It is mapping the IP address to the MAC address. So in this case, PCA will have a MAC address. And also it has an IP address. But to reach outside of its subnet, it has to go its gateway. Gateway is something that is living on the layer 3 device like a router or a switch where the ARP table lives. So in this case, where is the arc table living, guys? In this diagram, where will be the arc table living? Someone said something. Okay, let me answer that. So the routers are where the arc table lives because the routers are binding the IP address to the MAC address, right? So the router 1 or router 2 will have the arc tables. That's where the PC has to route the traffic to go out of the subnet, because switch can do only MAC address validation. Switch will never know the IP address. It will look into the source MAC. When it does not know the destination, like Microsoft.com IP, what does the switch do, guys? When the switch does not know what is the destination, IP address or the MAC address, what does the switch do? Rajesh, what does the switch do? When it receives a packet, when it does not know the destination MAC, what does the switch do?
It will broadcast. And it doesn't know the destination, it will broadcast.
Correct. So when it doesn't know the destination, the switch will broadcast. So in this case, the broadcasting works on the router 1 and router 2. So the first packet went to both router 1 and router 2. So the router 1 will have an IP address that is configured as the gateway of this PC. So on the PC, you will configure 3 things. One is IP address, right? Second one is gateway IP address. Third one is subnets. So what are these 3 things? IP address is identifying the device that's in the network. We talked about this. MAC address is the individual entity given to the given by the vendor. IP address is that we assign the IP address in the network to identify that device. And the gateway IP address is that PC to go to which layer 3 device we assign the gateway IP address. So in this case, on the PC, if I give the router 1 IP as 10.10.10.1, and if I configure on the PC the gateway IP as 10.10.10.10.10.1, it will definitely take the path. Let me. Okay. So if I gave the IP address as 10.10.10.10, and if I gave the gateway as 10.10.10.1, and if I configure the same gateway IP address here, the path that it takes will be always PC to switch, switch to router, and router to the internet. But what if I configure this IP here, 10.10.10.1? Now, even though there is a link on the router 1, it will still go to the router 2 because the gateway is configured here. But will that solve our major problem? Meaning, are we having redundancy here? If I configure IP address as 10.10.10.10, and if I configure my gateway as 10.10.10.1 on the router 1, the path will always go to router 1 and will go to the internet. But what if the router 1 go down? Is it solving my problem of having a backup router, guys? Is it solving it or no?
No,
No, it is not solving.
because you have configured.
Because I manually configured the PC1 going to switch 1 and switch 1 going to router 1 and router 1 fails, my traffic is lost. I don't have the redundancy working here. But the PC1 going to switch 1, what if I configure 10.10.10.1 on both IPs, both devices, sorry. So what if I configured 10.10.10.1 and 10.10.10.1 on both devices, then what is the benefit here is we have two devices with the same IP configured as gateway, right? So then switch gets a response that I am 10.1.1.1, I mean 10.10.10.1, and I am also 10.10.10.1. For the broadcast, it got two replies. But how does the switch know which to choose? Whether to choose the router 1 or router 2? How does the switch know? Switch does not know. That's why we introduced a concept called FHRP. What does FHRP does is, it will make both the routers communicate with each other using the FHRP protocol, and they both come to a conclusion of which one is primary, which one is secondary. That comes with the priority. Someone told about word priority, they use the word correctly. So whichever has the higher priority, that router is preferred. For example, the default priority on this router is 100. The default priority of this router is 100. So in this case, this one and this one, we need to make sure the path always takes the router 2. What I'm going to do is, I'm going to make this priority as 110. So this router and this router will communicate, even though they have the same IP address. Only the primary router responds to the switch saying that I am your destination MAC. So to reach to the gateway, you have to come to me. So that is how the switch will always send the traffic to router 2, because we put the high priority here. What if the router 2 went down? If the router 2 went down, the router 1 and router 2 will automatically send the keep alive using the FHRP protocol. Because the router 2 went down, the router will take over the primary role. Switch will get the update packet. Switch will get the update from the router 1 saying that, hey, I am your gateway. So next, the PC will send to switch and the switch will go to the router 1 because the router 1 became primary. So the FHRP is the protocol that is running between the routers to elect which one is primary and which one is secondary. So that is how they elect using a priority number. So whichever has the higher priority, that one will become the primary device. What if both the priorities are same? What if both the routers' priorities are 100, 100 on both sides? Then which one will become the primary and which one will become the secondary? That's a question to Sai Sri. What if both the priorities are same on both the routers?
Because the IP address is also same as we configured the same IP. Okay. I'm not sure about this.
Yeah, but you raised a fair point. The IP addresses configured are the gateway IP addresses, but those are not the interface IP addresses. So the interface IP
So then we'll check the interface IP address, which is the lowest one, that will be the primary, and the next one will be the secondary.
Yeah, in this case, it's reverse. The layer 3 works on higher IP address wins. It's not like spanning tree, lower bridge works, but it's reverse here.
Okay.
higher IP address
Okay.
means, not the lower one. So the
Okay,
interface
got it. Yeah.
will, whichever has the higher interface IP, that one will win the election, because the gateway IP you configured is same on both sides. So we cannot elect using that. That's why we chose the interface IP. Which one will have the higher interface IP? That one will win the election. So that is clear. What if, let's erase few things. I'm sure it's very clumsy here. Order one. Let me pick Vishal Neetha Devasamy. Vishal, is this your first class?
Yeah, this is my first class.
Have you gone through the recordings?
No, I haven't seen through the recordings.
Okay, yeah, please do follow the recordings. And yeah, thank you. Okay, let's start with Ritik Tota. So router 1 and router 2, they both talk using the priorities, right? So what if the link between them go down? What happens if the router 1 and router 2 link go down? How does the HSRP know which router is primary and which router is secondary if this link go down? This is a question to Ritik.
Okay, so will it consider the MAC address?
HSRP works on layer 3.
Yes.
Now tell me whether it works on the MAC address or not. You tell me.
No.
Okay, so that is taken out.
Okay. So if link goes down, then we can't consider interface IP address, right? So
No, there is no communication between both the routers.
there's no communication.
That link went down. So what will happen? What will happen is this router will say that, hey, I am your primary. And this router will say, hey, I am your primary. The switch will get confused and there is an outage. Routers can no longer go to the Microsoft.com. So to avoid this, we will put one more link here and we bundle them in a port channel. So always remember, when you are running HSRP or VRRP or something, between your layer 3 devices, use a port channel. That way, even if one link go down, you have another link which will be backing you up.
So basically, we are always maintaining redundancy. First of all, having two routers for redundancy. Again, having two links between them. So we always make sure that there should be a redundancy. Fine, ultimately.
Exactly. As an engineer, as a network engineer, your responsibility is to make sure your company network is up and running all the time, even you are sleeping.
Yeah.
Yep. If something happens in the network, one link go down, you should be backing your network. That's why you have seen people losing jobs when they don't plan their network well. But you get the idea here. So think about how can we make this network fully redundant. If something bad happens on one device, how can my network withstand by itself and make sure the clients are getting the network always? I think that's enough for today. We are end of time. I think there was a gap in your answers from last week to this week. That is because of we did not go through the test and you guys did not study it over the weekend. I think some of the concepts are already gone from the mind. That's why the answers are not matching to my expectations. So because we missed the last week test, I'm going to give the test today. So the test will be the idea of the test is giving 10 questions to each person. You have to record the answers like a voice message in your own words for those 10 questions and send that voice recording to the email address. Just pop it or just drop it there. Why we are asking to record is when you're talking to a vendor or when you're talking to an interviewer, they will ask you to explain about an answer. Then you should be able to explain that concept to the interviewer, not to me. So my idea or this whole program idea is to get you a job, not get you a certified CCNA. This plan is to get you a job. This plan is to make you sit in the interview and crack the job. So that's why we came up with an idea of recording the answers, not writing it on the theory. So everyone will be getting 10 questions. So please drop your emails in the Google Drive. I think last time few people did. Some of them send those answers. I'm still reviewing those answers, guys. I'll get the results to you next week. But for now, please go to that spreadsheet, put your emails there, and I will go through your recordings one after the other, or I have an helper who will be going through your recordings. He will report to me if someone answered well or not. If I cannot go through all of your recordings, I also have a helper who can help me with that. So let me stop there about the questions and all. We can discuss that more. But tell me, what do you guys have any doubts on this class or from the previous week classes? Because we are coming to almost end to the switching, we will go to the routing very soon in this week. We missed one class, guys, on the last Friday. I need one more extra class to cover. I'll put a poll. Maybe this week or next week, we need to take one more extra class to cover what we missed last week, because we are running on very tight timelines, guys. So that's why we wanted to make sure that we complete the course as per the norm. I have to present you guys to Venkat Garu as per the needed time, and he also would like to pay for your certification, CCNA, and he likes to see few of you guys get certified. I want to see all of you certified, but at least few of them need to get certified. Once after the course is done, we will give you some of the links where you can go through the books and all. But that's the plan, guys. Any questions from your side?
So if we post the assignment today, do we need to submit by tomorrow morning or by afternoon?
I'm not sure how many of you are really working. I don't know. Let's say if I give you tomorrow morning, can you guys do it by Thursday evening?
Tomorrow is Tuesday. I guess, yeah, I will be able to from mine.
Yeah, so Tuesday, Wednesday, Thursday, by the end of Thursday, that means that I think you're getting like 3 days, 3 full days. I think that should give enough time to get better at it and answer them, right? So that's the plan. Please post your emails there. I'm going to put those questions. I think we will do the similar thing, like you see your own tab in your spreadsheet, you will go through your questions and then you answer them accordingly with that questions. But networking will be rough if you don't recollect what we have gone through the last week. I know you will understand it easily when I speak, but you will keep forgetting them unless you make it as a routine. See, networking is not a diet; it's your lifestyle. When you stop your diet, you will put on your weight back. So networking has to be your lifestyle, not your diet. Keep that in mind. You have to keep on reading. Make it a lifestyle of reading networking every day, whether I teach the class or not. Yeah, so that's it, guys. I think I'll stop the recording here. Give me 1 second, and then I'll open it for any other questions or anything more.